Good morning, good afternoon, and good evening to all of our attendees joining us today for this latest Data Science Central webinar. This is Bill Voorhees, your host. I'm the Editorial Director with Data Science Central and also Chief Data Scientist for Data Magnum. I'd like to start off our event today by thanking IBM for sponsoring today's event. IBM's a longtime supporter of the Data Science Central community, and we're honored to have them sponsoring our event today. Now, past webinars are available on demand at datasciencecentral.com. If you haven't had the opportunity to view them, I encourage you to take a look. They provide very useful insight into a wide variety of topics of interest to our data science community. Now, today's webinar is entitled Powerful, Flexible, and Accessible Code-Free Data Science, to be presented by IBM. And before we begin, I'd like to briefly review the format of today's webinar. Today's event will be an hour long. We'll have two presenters that I'll introduce in just a minute. There'll be 10 to 15 minutes of QA following the presentation, and this event is being recorded and will be available on datasciencecentral.com later this afternoon following today's live event. Now, I'd also like to encourage our attendees to provide questions throughout the presentation. We'll be reviewing and presenting them on your behalf during the Q&A portion of today's event. Well, I'm very pleased to introduce today's speakers, Ted Fisher and Erica Reuter with IBM. Now, Ted is the Senior Offering Manager for IBM SPSS Modeler and is the Lead Offering Manager for IBM SPSS Data Science Offerings. He's responsible for creating the roadmap for IBM SPSS Modeler and ensuring the success of the product. Before moving to offering management, he had worked as a data scientist consultant for the U.S. government agencies, finding fraud and risk using IBM SPSS Modeler. Now, Ted has built predictive models and provided technical leadership to a team of other data scientists. His models, deployed in IBM SPSS Modeler, have identified billions of dollars of fraud, and the work has resulted in 2 awards from the Association of Management Consulting Firms. Now, Erica is a technical sales specialist with IBM with a focus on government agencies. In her role, she helps agencies determine what resources best fit their unique needs and introduces them to opportunities and/or new technologies as they emerge. And prior to working with IBM, she spent 16 years employed in public safety agencies, working in various roles and concluding as the manager of a crime analysis unit for an outstanding medium-sized police department in South Florida. She holds numerous law enforcement and IT certifications, as well as a PhD in criminal justice. So Ted, Erica, thanks for being with us today. We're looking forward to your presentation. As the demand for data science expertise grows, so does the need for tools that deliver flexibility, speed, and ease of use. Now, organizations need solutions that can access several data types, such as big data, offer a vast library of algorithms, including the most popular open source methods, and are accessible to expert coders and non-coders alike. In today's Data Science Central webinar, we'll learn more about the newest IBM SPSS Modeler capabilities, such as Python algorithms for non-coders to provide greater analytical power and flexibility, seamless integration with IBM Decision Optimization to help you determine the best scenarios for your business and budget, easier access to data from the weather company, enabling you to create weather-driven insights, and learn how IBM SPSS Modeler can help data scientists and analysts to extract important insight from data in powerful, flexible, and easy ways. So Ted, with that, I'm going to turn it over to you. You can begin as soon as you're ready to go.
Yeah. Thank you, Bill. So here's our title again: Powerful, Flexible, and Accessible Code-Free Data Science. So SPSS Modeler has been around for many years as a leading tool to do data science, both actually code-free and with code as well. So, as we all know, digital businesses are disrupting industries and professions, and if we can go look at Airbnb, Amazon, Uber, and Facebook, they are all disrupting every industry pretty much. So how do we win in this market today? So to do that, you have to take advantage of the data that's in your organization. Traditionally, data was used for operations purposes to find efficiency, and then it moved on to reporting and data warehousing. And over the past few years, we've definitely seen the rise of self-service analytics, where business analysts can go find their own data, leading to more democratization. But now we're approaching the case where data science can not only be a self-service analytics capability, but actually lead organizations to new business models and new revenue opportunities. So what is data science? We define data science as the concept to unify statistics, data analysis, and the related methods to understand and analyze an actual phenomena. Notice that there's no requirement to code, and there's no requirement to have a PhD. So although the picture shows lots of mathematical drawings and capabilities, you actually don't have to have a deep understanding of them. You just have to understand what they do, not the inner mathematics behind that. So data science is applicable to pretty much every industry out there. There's lots of use cases. They generally group into three areas: customer analytics, trying to understand your customers to grow your business; operational analytics, to see, are your operations efficient? Can you make them more efficient? Can you prevent problems in your processes? And then finally, fraud and risk. Trying to find fraud and risk in your operation. But again, but there are particular use cases in particular industries as well. So how do we actually put data science to work? Well, the most important need is to clearly articulate a use case. So, if you don't, you have to identify what exactly you're going to use the data science techniques for. If you don't do that, you're going to struggle with subsequent processes. So once you have that defined use case and exactly how you use data science, then the important thing, then you have to gather and prepare your data, which traditionally can take a very long time, up to 80% of your project. That's because in many organizations, the data is not in one place. It's not clean. It's scattered all around, and it takes time to understand the data and make it suitable, put it on one place that's needed for modeling. Once you have the data in one place, then you can model the data, create your predictive model, evaluate the model, and then most critically deploy that model into another application. Now, IBM SPSS Modeler supports the entire life cycle that's shown here. So you don't have to use multiple tools to do all this. You can do this all in the IBM SPSS Modeler. So another thing we've learned at IBM is that data science is a team sport. So while some may say you need one person that can do everything around data science, it's often very, very difficult to find that person. So you may need to find, for instance, may have some technical data scientists in your organization, people who know R and Python. You may have data engineers in your organization, people who know how to manipulate and change your data. You have application developers, the people who integrate the models into the operations. Business analysts help understand what's coming out of it and also define requirements. But then also you have this other category called the business or citizen data scientist. And that's a person who maybe doesn't know R and maybe doesn't have a PhD, but has some statistical background, has some background in predictive analytics, and is able, with the right tool, to do data science. So what we at IBM, we actually have different offerings that apply to these different types of people. So, for instance, developers can use Bluemix, business analysts can use Watson Analytics, technical data scientists can use Data Science Experience or CPLEX. But today, we're going to talk about IBM SPSS Modeler, which is the right tool for the business or citizen data scientist. So let's talk more about the citizen data scientist. So as I said, in theory, you could go try to find a person who knows R and Python and is an expert at all the algorithms and Hadoop and can drive the algorithms from first principles. But in practice, that's almost impossible to find. So the best way to really take advantage of data science in your organization is to take other people who have some background statistics, some background in the area, and train them and bring them up into your organization. So, and so Gartner has predicted that the number of citizen data scientists will grow 5 times the number of regular data scientists because there's just not enough regular data scientists to go around. And because there's more and more automation in data science tasks, it will be easier and easier over time for these citizen data scientists to enter the field. And so it's going to, by taking advantage of these other people in their organization, people who aren't necessarily, have the label of data scientists but can do the tasks, especially with a GUI-based tool, organizations are going to really achieve tremendous value. So let's now talk about the new version of IBM SPSS Modeler that came out in June. So the first, there are 3 themes that are part of this. The first one let's talk about is the further embrace and extend open source with an emphasis on Python. So when we say embrace and extend open source, this is something that within SPSS Modeler we have focused on for quite a number of years now. So not only can you run R, Python, and Spark, you can actually extend open source, meaning you can build a little GUI that runs on top of R, Python, and Spark, and then the data scientist coder can then share that with the citizen data scientist, and that allows the citizen data scientist to really use that capability. So it makes it massively useful. So we're not just saying, hey, you can use it open source. We're actually making open source easier for everyone in your organization. So what does it exactly mean? So so here we're showing an example of the interface that you can use to create the little GUI. So you can, the data scientist programmer can write R or Python or Spark, and when we write Python, they can access any of the most common libraries such as scikit-learn, NumPy, SciPy, or Pandas. And then they can create what we call a modeler node, a little GUI that actually runs on top of the open source code. So we're extracting the code behind the GUI and making the code usable for non-programmers. So here's a more concrete example. So on the left is some Spark Python code running the Spark collaborative machine learning collaborative filtering algorithm. And on the right is a way that the non-coder can access that Spark collaborative filtering algorithm with drop-down menus and tabs and clicks. And so what the programmer defines the interfaces that the non-programmer will see, but the non-programmer can then access that Spark collaborative filtering algorithm. So here, in this way, we've taken this very useful library from Spark and made it accessible to the non-coder. So here's some more examples of the extensibility with R. So you can create graphs, you can do processing, et cetera. So if you have any additional questions on this, please feel free to ask. So, but in the most recent release, we did focus on integration with Python. So we've had a very good integration with R for many years, and we're not ignoring R, but we did focus this release on Python. So why Python? So Python has many analytic libraries with good documentation and a consistent interface, whereas R, each algorithm tends to have its own interface or its own way of doing things. So it's a lot of more inconsistency. In particular, the scikit-learn library has a curated set of machine learning algorithms that are suitable for many tasks and scale well for many problems. We've tested this ourselves at IBM and found they work very well. And finally, Python is a general purpose language, so often easier to learn. So especially for people who are new to data science or come from a general programming background, then approaching data science with Python is actually often easier than approaching it from R. So what we have done in the most recent release is to add native capabilities that run on Python in IBM SPSS Modeler. To do this, we now embed Python in Modeler, so now you don't have to download it, install it separately. It comes with the product. But then we've also added a number of algorithms, including XGBoost, that run on Python directly, but it's available via the Modeler GUI. And I will be going over each of these in turn. So let's first talk about XGBoost. So XGBoost is a very popular algorithm, frequent Kaggle winner, and it stands for extreme gradient boosting. So it's a technique where many models are built in sequence with each iteration dependent on the prior iteration. The features include speed and training and model performance. And there's sort of we expose two different ways of running XGBoost in Modeler. The first uses the classification regression tree method, and then the second is a linear regression. So the tree method is good for estimating discrete values or predicting outcomes, while the linear regression method can be used to estimate numbers. When boosting, the XGBoost method minimizes training loss, so it makes sure that the model really fits the training data, but also uses regularization to minimize complexity. So again, this is the same XGBoost that's available in Python, but now again available in Modeler itself. So another method that we've added is SMOTE, which stands for Synthetic Minority Oversampling Technique. So we've had balancing in Modeler for quite a long time, and balancing is a useful technique to deal with rare event modeling, where if you only have a small number of observations of the event you're trying to predict, you can oversample or duplicate the observations of the least common event, or you can undersample the more popular event, or do both. So, but the balance node is fairly mechanical. It just duplicates observations or samples. What SMOTE does, it actually creates synthetic data points by using a k-nearest neighbor methodology that interpolated between the rare data points, and can improve the result to find for rare event modeling. The final new technique we've added is called OneClass SVM, and this is a novelty detection method. What this does is, if you have some data that it tries to find data that does not fit well within what your training data has. So the assumption is that your training data only has regular patterns. It does not have anomalous or non-conforming data points. But then what it will then find when you score this model, those anomalous or non-conforming data points that do not match the training data. What we found, though, in our testing is that even if the number of contaminated data points is relatively small in the training data, you can still use it to build the model. So OneClass SVM also works as an anomaly detection method. So the most useful application is, again, in fraud or risk, where you want to find if there are new patterns in your data, because a new pattern may represent fraudulent activity. So other open source integration. So in Modeler 18, the prior version, the only way you can run Python was with a custom node. Now you can actually put Python code directly into Modeler without having to create a custom node, just the same as R. In addition, in the past, you couldn't explicitly import or export data through an extension, although you had to use a process node, which is a bit kludgy. So in 18.1, you can explicitly use open source to read in or export data through an import or export node. In the past, for R, you had to run only a supported version. If you tried to run an unsupported version, you got an error. So now you actually can run any version of R, although we still only support one. What happens is if you try to run, if you open a ticket with IBM on an unsupported version, the IBM support will only try to replicate the problem with a supported version. However, this will allow you to run a newer version of R that's available even before we officially support it. Note, for Python, we only support version 2.7, so this more openness only applies to R. We also bundle now Spark 2.0 with Modeler. So next, let's talk about integration with other offerings, CPLEX, Weather Company, Hadoop, and others. And I'll focus here on CPLEX and the Weather Company. So let's talk a little bit about optimization. And what is optimization? So optimization is a way to make sure your organization can manage resources efficiently and make decisions based on those resources. these resources can include things like capital, people, equipment, facilities, etc. And you know you have an optimization problem if you hear words like you want to minimize or maximize, you want to figure out how much of something or when or where, or there's a need to decide, choose, plan, or schedule. And the way this works is you take your business goals or KPIs such as increased profits, increased revenue, increased sales. You then decide, okay, well, what decisions impact the goals? So, how much we should produce, what marketing campaigns we should run, how we should schedule something, and create variables. And then you decide, you figure out the rules or constraints that impact those decisions, such as budget, capacity, et cetera. And what I have found in my experience is that optimization can be used in many data science problems. A predictive model, in the end, generally produces a score or a number, or maybe like a simple prediction. It doesn't produce the business decision that many end users want because it doesn't take into account the costs or the constraints, as I previously mentioned. So by adding optimization into your predictive project, you can really translate these numbers that are produced by the model into an effective decision. And now you can do that directly in Modeler. So what we have done is we've added, IBM has the leading capability in optimization in its CPLEX portfolio. And so what we've done is have embedded the community edition, which is the free edition of CPLEX, which works on about 1,000 rows of model data in Modeler. But if you have a license for CPLEX, you can remove this restriction. So the expert who knows this language called OPL can create the model and specify the data, allocate fields to OPL, and then allocate output field names. And the result is we can actually run the optimization problem directly in SPSS Modeler. So this means we can also schedule it through our collaboration deployment services capability. And in addition, we also support accessing CPLEX through the Python API through an extension. So we have multiple ways of running optimization in Modeler, and this optimization capability really adds value to your business problem, and it's not something that a lot of others can do. So let's now talk about another new capability in SPSS Modeler, which is weather data. So recently IBM bought the weather company, and the reason that we did that is because weather has a widespread influence in business. Bad weather can cause insurance claims to go up, temperature increases affect predictive maintenance, affect reliability of utilities or manufacturing process. Weather affects shopping behavior. People don't tend to go shopping if it's really cold outside or really hot outside. It also affects other things, things like crime. Crime depends often on how warm it is outside. So adding weather data to your model will often have a significant impact and can improve the lift of your model. So what we have done in SPSS Modeler is have a direct access to the weather company data. So if you have a weather company subscription, you can actually access weather data for a particular location directly into SPSS Modeler. We've also previously published extensions that access other weather company capabilities. This new native capability is in addition to that. So we think a lot of industries will find this a very useful capability. So the final point I'd like to talk about the new capabilities is text analytics for big data. We also had some usability improvements in Modeler, but we'll reserve that for the questions. So let's talk about text analytics. So text analytics is a way to convert unstructured data into structured data for further analysis or insights. And there are many use cases: customer analytics, social media, industry analysis, fraud analysis, etc. Many algorithms can't accept unstructured data. So by converting it to structured data, you can improve lift to all your models in these use cases, and lets you take advantage of data sources such as call center notes, documents, publications, web pages, etc., which are often stored. These items are often stored in unstructured data, and you need text analytics to make them useful for your predictive models. So this will allow you to better understand your customer behavior. So text analytics has been an important capability in SPSS Modeler for many years. Again, not not too many other company products, data science products have this kind of full-fledged text analytics capability directly in the product. With this capability, you can really customize your text analytics analysis to get exactly the kind of outputs you want. So it comes with pre-built libraries for common use cases, but as we know, many organizations use particular jargon or particular terms that are not in common use. What's great about the text analytics capability is that it lets you really customize and really get out exactly the information you want out of your unstructured data, and convert it so you can convert it to structured data and then make it useful for your models. So we made a significant improvement in the most recent version of SPSS Modeler by moving the back end to System T, which is a scalable text analytics engine. So System T is multi-threaded. This will allow the text analytics to scale better for larger data sets if run on an appropriate sized computer. We also added capability to detect the language of the text. So if you have some text that are Spanish and some text that's in English, you can basically have different processing paths for the Spanish text and English text, or apply different text analytics libraries based on whether it's Spanish or English. We also now support text analytics on Mac. So, okay, so finally I'd like to discuss, we have that IBM is a leader in data science. Both Gartner and Forrester have recently said IBM is a leader in data science. And so, so as you consider the tool you're using for data science, you should please, we would ask you consider IBM, because we've had the history, we have the experience, and we have the capabilities, including the integration with open source. All right, so I'd like to turn this over to Erica Reuter for a demonstration.
Thanks, Ted. For those of you who aren't familiar with SPSS Modeler, I'd like to take a moment just to show you the solution, just to get you a little familiar with the interface. This white area you see here is what is known as our canvas, and this is where we build our predictive models. We build them using these icons or nodes you see here at the bottom. So each of these nodes represents some manipulation of the data. For example, under sources, I can drag these nodes representing different data sources. If I'd like to add a database node, I can just drag that to my canvas, double-click and open it up, and point to where that database lives in my computer. If I'd like to add an Excel, again, I can drag that to my canvas, double-click to open up the node, and point to where that Excel file lives on my computer. So that's how we bring data in. Versus writing, again, code to retrieve the data from whatever source we'd like to get it from. And then, you have your natural cleaning and data prep tasks that are located under record ops when we want to affect the record or the row, and field ops when we want to affect the field or the column. So perhaps I'd like to merge these sources together. I can do that with a simple merge node. Right-click on the sources and connect them to this merge. And then just select a unique key to do our join. So we can join these together, despite the fact that these are our sources that are not on the same server. They just need to have that key together, or we can sort based on order. So as you can see, the idea here is, even though there's a lot of advanced math, a lot of advanced computing going on, it's all happening behind the scenes of these nodes. It truly is code-free. So now that we're familiar with the general flow of how we build these predictive models, I'd like to go ahead and dive into some of those features that Ted mentioned earlier. I'm going to start with the weather. Quite a few of my clients do want to incorporate weather into their predictive models. A lot of our retail customers feel that, for example, sunglasses might sell better on a sunny day or a rainy day, or it might impact store volume. In this case, a lot of my law enforcement clients look at weather for auto burglary, for example. Maybe people are less likely to break into a car if it's raining outside, because it's not worth the trouble. They don't want to get wet. So what we're going to do is very, very, not deeply, very shallowly. We're going to look at some crime here. So I've pulled in 100 crimes from the city of Chicago from their open data portal. And I can click preview, and you'll get an idea of what we're looking at here, the kind of data we're working with. So these are just, records from their records management system, their RMS. And we can see what kind of crime happened, and information that was collected at the time, the latitude and longitude, the date, so on and so forth. Now, to bring weather in, we have this new source now, the weather company import that Ted mentioned previously. I'm going to drag that up here and double-click and open it up. To bring weather in, once I have an API key from the weather company, all I have to do is enter the latitude and the longitude for the location I'm interested in. So for Chicago, I have it entered here, but I'll show you that in a second. So I'd enter the latitude and the longitude, and then I can indicate if I'd like to pull in historical weather or a forecast if I'm going to be scoring. So I can just say, bring me all the weather from 2001, 01, through 2001, 01, 02, and it'll give me a historical what happened on that date. I pop in my license key, and it's going to give me that pull. So what I'm going to do is I've already populated that here, but my license key's in there as well, so that's why I didn't open that node up. And I'm just going to click preview, and you'll see what the weather company is pulling in through that API. So for this latitude and longitude in Chicago, 41.872 and minus 87.713, and the time parameters I've specified, it's giving me information such as the temperature, the dew point, the heat index, the cloud coverage, that sort of thing. So now I have weather introduced as a variable in my data set. I want to say it was maybe 2 releases ago, but maybe even within the last year or 2, we've introduced these space-time boxes. And these are incredible because what this does is it takes that latitude and longitude information and it allows me to put that into geohashes and give it a time dimension. So for those of you not familiar with geohashes, essentially what happens there is we grid the Earth up into 32 boxes. And that represents the first digit of a geohash. And for every digit that we continue on, we're dividing that box into 32 sub-boxes and 32 sub-boxes of that box. So we get incredibly granular. So to have the computer calculate that for us and do that grid for us, we indicate the latitude and longitude of the location we're looking for. And then we tell it where is our time located in our data set. So now it knows how to pull that information in. And I indicate a density. So I can go down as far as 19 meters here and say, all right, I want you to make boxes that are 19 square meters, and I want you to make me one for every 4-hour time period. So now that I've done that, I've gridded my weather data. I've also gridded my crime data, and I can do a merge on those space-time boxes. So again, I'm going to right-click and click Preview. And you'll see this is the space-time box that was generated, giving me my latitude and longitude. And now this weather data that we've pulled in from the weather company, rather effortlessly, honestly, is now merged together with this crime data. So I can go ahead and use that and model on that using weather as an additional variable. What's been added also in here, which is, again, neat, is let's say, this police department or whomever this client is builds their predictive model, and now they'd like to use those predictions to deploy officers appropriately. They can even use our CPLEX optimization now that Ted mentioned, and perhaps use that for scheduling. So they might want to use the results of the prediction, union rules, all sorts of different ideas to schedule officers most efficiently to minimize their expense to the agency and maximize their return on investment. So that weather import, I think it's pretty neat. Now, this is Data Science Central, so clearly quite a few of you are interested in open source integration. So I'd like to show you this extension hub. We, for several years now, have had people contribute and be able to use open source code within these custom nodes. And this extension hub is neat because it allows our users to have a community where they can share with each other, they can contribute, or you can get these off of GitHub. So these were written by business partners, by IBM, by our community. So if I wanted this Watson machine learning extension, I can go ahead and just click Get Extension and say OK. and accept the terms and say finish. And that's going to add that extension that was built in open source here, right here on my palette. So I'm going to just drag that on up here. And you can see it looks like any other node when I double click and open it. So, again, people who are not familiar with open source, with coding in Python and R and Scala, can go ahead and use this thing that's been pre-configured for them. Now, this custom node dialog builder, as Ted mentioned, is how we build these. And I want to just, again, dig just a teeny bit deeper. And I'll do that by opening this installed node here, this Watson Machine Learning that I just brought in. And that's going to show you here, this is the actual script that was used to build this node. So you can see, if you wanted to build something like this, it's very similar to Visual Studio, adding your controls, adding your script. It should be fairly familiar for developers. So again, this just allows you to perhaps build a custom node within your company and allow those citizen data scientists to take advantage of the work done by your traditional data scientists without having to learn the script. Okay, so finally, let's take a look at some of these new algorithms and techniques that have been included in Modeler 18.1. So we have this Python tab down here below. And you can see this is going to expand, but you can see immediately that for those of you who are interested in gradient boosting, you have your XGBoost options here, as Ted mentioned. OneClass SVM from scikit-learn is here. But we're just going to spend a moment on SMOTE. So again, as Ted went over previously, SMOTE is used for balancing data. It's an oversampling technique. And we're going to look at credit cards. We're going to look for fraudulent activity within credit cards. So I'm going to open this node up here and just click Preview. This data has already been prepared for us, and it's put all kinds of variables into a number of columns. But the one that we're going to be looking at here is this class variable. With a 0 indicating fraudulent activity, a 0 indicating normal activity and a 1 indicating fraudulent activity. So once the data is brought in, we can go ahead and partition it with a partition node into a training, testing, and validation partitions. And then we always add this type node whenever we bring new data in, and I'll double click and open that up. And what the type node does is you just click read values, it reads everything in, it assigns it a measurement type, which of course you can change. And then with the drop down, you just let the computer know which field is your dependent variable or your target. So in this case, we would like to build our model around whether or not these transactions were fraudulent. So this is that traditional balance node that Ted was speaking about. This is a graph that I've brought in off this graph tab here, a distribution. And we're just going to graph that class variable to see how many of these transactions are fraudulent, how many are not, how many ones do I have, how many zeros. And when it's done running, you can see that it is heavily unbalanced. We have very few, less than a percentage of records that are fraudulent, indicated by ones. So what we're going to do here is going through first and taking out the validation records. And we're just going to do a random trees, similar to a random forest, because as many of you, I'm sure, already know, random trees and random forests have the options to handle imbalanced data as part of the algorithm. So we're going to go ahead and run that. When I run a modeling node, just the right click and run, it generates a golden nugget that houses the details of our model that we're typically used to seeing to evaluate. I'm going to go ahead and look at this analysis here. And that's going to give me, again, just analysis of how well the model did. We're going to look at the area under the curve and the Gini score. And then once that's done, we'll do the same thing. We'll run it through SMOTE and uncheck the option to balance the data within random trees. And then we'll run both through validation and kind of compare the results. So as you can see for a baseline here, we're looking at a 0.966 and a 0.931. Fairly good. So now going back to where we stopped here, stripping out the validation records, we'll run it through SMOTE. So again, we just have to tell the computer which field is our target field or our dependent variable that we'd like to balance out or oversample on. And there are three kinds of algorithms. So if I were to choose the regular algorithm, it would create synthetic records of the minority class only. Borderline 1 would strengthen the border around using the minority class records, and borderline 2 would strengthen the border of the minority and majority class records. So we'll leave it at regular and then run it again through random trees. This time, though, the handle imbalanced data is unchecked. So again, same procedure, ran it through, ran an analysis. Now here's where it gets interesting. Going back to the beginning here, before we stripped out the validation records, I'm going to go through this time and only select the validation records. And then I have this golden nugget here, which is a copy of the node that was created using random trees balancing the data. These filter nodes here are just changing the name of the field, so it's easy to compare the results of SMOTE with and without. And then I have a copy here of the model that was generated where SMOTE balanced the data for us. And then again, filter just to change the name, so it's easy to compare the results. And then under the analysis field, I'll go ahead and click Run once again with a right click and a run. And we'll be able to compare and see how SMOTE did versus using the balancing in the random trees. So we can see without SMOTE, we're looking at an area under curve of 0.949 and a Gini score of 0.899. And then with SMOTE, 0.958 and 0.916. So no surprise, I'm sure, to the Python users on the call that it performed rather well. And we're happy with the results of the algorithm. So again, very briefly, we just covered how we can now bring in weather data from the weather company using our weather source node, using the custom dialog node to have some of those open source capabilities, and again, some of the Python nodes that are now available out of the box within Modeler 18.1. So with that, I will turn it back over to you, Ted.
All right. Bill, do we have any questions on the chat?
Well, Ted, yes, we can move into QA if you're ready for that. Is that your intention?
Yeah.
Okay, great. Well, Ted, Erica, hey, thanks for that excellent presentation. And we'll get started with today's Q&A session, and I want to thank the audience for their participation. We've had a lot of questions that have come in during this presentation, and so we'll do our best to get through all of them in the time remaining. And during this Q&A session, I'll leave up this screen. Wait, here it comes, with contact information for Ted and Erica if you'd like to get a hold of them following today's event. So let's get started. So Ted, Erica, question from the audience. What are the improvements in terms of how SPSS Modeler now works with Hadoop?
Okay. Yeah, so I'll take that. As I mentioned earlier, we did create some improvements with Hadoop, but let me first just step back and see what we had before. So we have an add-on module to IBM SPSS Modeler called Analytics Server. And what that does is that actually pushes the analytics back into Hadoop. You can actually build, do your data processing, build models, and score models all in Hadoop via the Modeler GUI, but all the analytics are pushed back into the Hadoop cluster. And if Spark is installed in your Hadoop cluster, the processing takes place on Spark. However, we've had some customers that have said they don't necessarily want the add-on module and really just want to tap in Hadoop as a data source to Modeler. And so they are willing to have the data move from the Hadoop cluster into Modeler. So as a result, because of those customer requests, we have added some integration from Modeler into Hadoop directly. So you can have Modeler read in from Hive. Modeler will also be able to read in from Hortonworks via the IBM's big SQL offering, and also Modeler can read in from Cloudera via Impala. Now, for Hive and big SQL, what we also will push back data processing. So we have this capability in Modeler called SQL optimization that pushes back common data processing operations such as merging data, adding fields, et cetera, into SQL. Well, that kind of capability will also push back into Hive or via big SQL into Hortonworks. Model building, though, will not push back. The data has to be extracted into Modeler from the Hadoop cluster. The connection with Cloudera and Impala is read-only, meaning we don't push back data processing. But as a result, if you want to use Hadoop as a data source into Modeler, in Modeler 18.1, you can do that without the need for the add-on module. But if you want to make sure that data never leaves your Hadoop cluster, you still should have analytics server.
Well, Ted, hey, thank you for that excellent answer. Another question from the audience. Now, we know that SPSS Modeler has had embedded algorithms all along, but what does this focus on open source algorithm mean for the existing embedded algorithms?
Yeah. So no, that's a great question. No, we are not de-emphasizing our regular algorithms. They are still all present. They're still all there, and they work just as well. But we have changed our focus in terms of the future. So what we have found is as I mentioned before, open source algorithms work very well. They are very powerful, and we've had requests from our customers say, "Hey, we've got these great open source algorithms, but we can't seem to use them in the product." And yes, you can use them if you create the extension, but not everyone wants to create an extension. So what we've done is, we've started, with XGBoost Smote and OneClass SVM, is to say, look, you can actually now run these Python algorithms out of the box. You don't have to do anything to enable them. So again, this is not to replace our existing regular algorithms, but this is to provide these best-in-class open source capabilities into the product, and we're hoping to do more in the future. So this is our message is we have our existing capabilities plus open source is a win-win for everyone.
Well, Ted, hey, thank you again for that answer. Now, this next question from the audience really divides the world into our two tribes: those that like to code and those that prefer a GUI. So the question is, what if I don't want to use the GUI but prefer to code? Does IBM have any offerings in that area?
Oh, I'll take that one because I'm actually really excited that it came up. Yeah, so we have something called the Data Science Experience, which is an evolution of the Data Science Workbench. But I like it. It's really cool. It allows you to use Jupyter Notebooks, RStudio, Decision Optimization, lots of machine learning, and it's all under one roof. What I really like about it is not only that it's allowing all of these to be inside one platform, but that it's basically data science as a service. So it's all running on Spark, which is managed for you. The libraries are managed and updated for you, which is huge, and it's got collaboration features that I like. So I can actually invite people in my organization to, view my notebook or comment on it or have editing rights or that sort of thing. So I don't have to, load stuff up to GitHub, pull it back down. I can all share it inside the platform. So yeah, Data Science Experience. If you're a coder, definitely check it out. Try the trial. I think it's kind of amazing.
Oh, terrific! Hey, thank you for that answer. Now, the audience has asked that you talked about some usability improvements during the presentation, and they'd like to have some more information about that. Would you comment on the usability improvements?
Yeah, sure. I'll take that. Yeah. So we actually had quite a number of usability improvements. So we didn't list them in the presentation because for lack of time. But I can go over them now. Some of them now. So one of the big ones we've added is autosave. So unfortunately, in the past, if you have Modeler open and your computer got rebooted while Modeler was open, and you've forgotten to save your work, you did lose what you had worked on. We have added a capability to automatically save your work every 5 or 10 minutes, and and then when your computer comes back up, it will automatically go to what was saved, and you'll be able to restart from there. So that'll hopefully save hours and hours of work for our end users. We've also added a capability around partial transpose. So in the past, if you wanted to change some rows into some columns or some columns into some rows, you could do that in Modeler, but it was pretty difficult. You had to use a lot of nodes. In fact, it was probably easier to do it in code. After a lot of requests in this area, we've added a capability, which actually runs on Python, to change some rows to do this type of partial transpose. And especially if you're working with timestamp data, you often have to transpose these transactions into columns, but you don't want to do it universally. You only want to change some rows into some columns. And this partial transpose capability will really assist on that. And then we've also added some GUI improvements, so you can now customize which algorithms you see at the bottom. As you probably saw in Erica's demonstration, we have a lot of algorithms, but not everyone wants to use all of them. So you can actually now hide the algorithms or even other nodes that you no longer want to see or use. We've added some improvements for those who do connect to Analytics Server, so you can only show which nodes are supported in Analytics Server fairly easily. And we've had some improvements to our time series algorithm, which makes it behavior more consistent with what happened in the past.
Well, Ted, hey, thank you for that clarification. Audience would like to know, here's the punchline. Okay, we've built the model and now we have to deploy it. Can you speak to the issue of what my options are for model deployment?
Sure. So we have an up-level modeler called Modeler Gold that adds in our deployment capability. And what that lets you do is takes the flows that Erica showed you, and then you can mark that, put it in a repository, and then mark that for deployment. Once that's marked for deployment, you can then invoke it via schedule, or you can use a web service call to invoke it in batch or real time, which allows you to integrate with existing applications. So the key thing is that the GUI, all the work you've done in the GUI doesn't have to be recoded at all. You can take that straight into our deployment engine, and then invoke it at your own desired schedule, or integrate it into an existing operational process via web service calls. So this greatly saves time versus having to code one version in development versus coding a different version in production. The deployment is very straightforward and has been built into mind in the product from the beginning. If you don't deploy, you don't get a lot of value out of your model. So with that Modeler Gold capability, you can definitely get the value you need.
That's right. Boy, deployment is where it's at. Now, yes. You talked a lot about how simple the new SPSS Modeler is, and how you're targeting citizen data scientists as well as the more sophisticated data scientists. But the audience has asked, well, exactly what skill level should a user have in order to be able to use SPSS Modeler?
The most important thing is having a really good understanding of your business. If you have a really good understanding of your business and how you feel things should be modeled for your business case, I think that's really what you need. Learning the math and learning the interface isn't terribly difficult, and we're here to help you with that. So it truly is designed for business analysts, for citizen data scientists, and you shouldn't feel, again, we keep talking about PhDs, you shouldn't feel that you need a PhD or that you need advanced training in predictive analytics to get started with Modeler.
Well, Erica, thank you. Terrific. And one last question from the audience. This release, obviously, you said focused on Python, but back up a little bit and tell us a little bit about the integration between IBM SPSS Modeler and R.
Right. Yeah, so I'll answer that. Yeah, so we've had this integration for quite a number of years, and what it does is, again, you can run any R program in SPSS Modeler, And it doesn't have to be an R program that does, machine learning. It could be an R program that does anything. And so in a sense, it can wrap around, for instance, APIs. So some of the extensions that Erica showed you, for instance, she showed an extension to connect to Watson machine learning, right? That's not necessarily a native, and it actually wrapped around an API that the Watson machine learning capability provided in R. So while you wouldn't think, wow, you use R to connect to another data source or another capability, you can do that. So anything you can code in R, you can, or actually Python as well, you can now run in Modeler. So this can also include things like data processing, graphs. R has the Plotly library, and with lots of great graphs, you can run them in Modeler. You can access otherwise unsupported data sources. For instance, JSON, we have an extension to read in JSON data, read in from CloudInt. So if there's a data source you need to get into Modeler, but it's not natively possible out of the box, you can certainly do that.
Well, Ted, Erica, thank you for some great answers to some very good questions. Now, for those of you that asked questions today that weren't answered, we'll be sending all the unanswered questions to Ted and Erica and the IBM team so they can follow up with you after today's webinar. So, Ted, Erica, before we wrap up, are there any last thoughts you'd like to leave the audience with?
Yeah, I'd like to leave up some last thoughts about Modeler. So why use IBM SPSS Modeler? So as we've been stressing, it's a visual code optional data science platform. It can be code free if you want, but you can incorporate R and Python code or Spark as well within the deployment. You can run straight code or make a custom interface that runs that allows the citizen data scientists to use it. It has advanced data manipulation capabilities, and we've improved that. As I mentioned, we have a flexible deployment, batch, real-time, and streaming without coding, and we have this integration with decision optimization and Watson machine learning, as we've shown. So if you want to try it, we have a 30-day free trial at ibm.com/trySPSS. You can get more information on our marketplace page as shown here. We also have a community where you can ask questions, and we constantly monitor the community for questions and try to answer them as possible. So I encourage all of you who haven't tried Modeler to get the free trial and then ask questions on our community. Okay, I think that's all I have, Bill.
Oh, well, Ted, Erica, hey, thank you for some great answers. We really enjoyed your presentation. And I have just a few quick announcements. If you'll please mark your calendars for September 20th, that's our next DSC webinar, which will be Real-Time Analytics for IoT with Apache Agent and IBM Streams, and also sponsored by IBM. Also, today's taping will be available for on-demand viewing later today, and you can find that on the home page of Data Science Central in the Webinar tab located at the top of the page. Well, this brings today's webinar to a close. I'd like to thank our audience for their attendance and thoughtful questions. And a special thanks again to IBM for their sponsorship, as well as our speakers today, Ted Fisher and Erica Reuter, for their insights into today's topic. My name is Bill Voorhees. I'm very pleased to have been your host for today's event. I look forward to seeing you all again on September 20th. Have a great day.